All right, class, welcome to section 8.2, solving systems of linear equations in three variables. So for the system of linear equations in two variables, I was able to show you, okay, we're crossing two lines. Now, an equation in three variables really represents a whole plane in a three-dimensional space. So these pictures I copied for you out of the textbook are trying to suggest three-dimensional figures just for us to see in how many points can three planes intersect. Okay, so here it is. As you see, these first three planes intersect in one point. And if you want to look around your room, think about the walls in your room and how many points could they have in common. So yes, the one corner of the room is the intersection points of three planes, the ceiling and two of the walls. So we again could get one solution. So one common point only to three planes. You can intersect three planes and get a whole line of answers. So in other words, infinitely many solutions. Or you can very well get no solution at all. And it doesn't even have to be that all three planes are parallel to each other. It could be enough that two of them are parallel to each other because, again, we're looking for the common points to all three planes. So if two of them will never meet, then all three of them cannot meet. And then there's another picture right here where only two at a time meet, but not all three together. So again, we can get no solution, we can get infinitely many solutions, or we could get one solution for these 3x3 systems, we would call them. Okay, so three equations, three variables. Okay. Now, definitely we can solve them by graphing because, well, we can graph such planes on three-dimensional planes on a plain piece of paper. All right, so we could solve by substitution, but they're not really geared that way to where you can solve for x, plug it in. It could, but it takes a long time. So the only method we're going to use is the elimination or the addition method. Again, some books call it the elimination, some books call it the addition method. It's the same method. By the way, it's elimination by addition. So it's suggesting that you will eliminate something if you add equations. So let me show you what we do. What we're going to have to do is try and get this 3x3 system down to a 2x2. So just two equations and two variables, which we then know how to solve because we have just covered section 8.1. Okay. So organized, this is what I will do. I will copy down two pairs of equations. It doesn't matter which two. I'm grabbing equations 1 and 2 as you see. And then also I'm grabbing equations 1 and 3. Or you could have grabbed equations 2 and 3. So two different pairs. And then what we will do is eliminate the same variable from both. So I picked this one because it's actually pretty nice. To eliminate x, it's quite easy. All I have to do is multiply the top equation by -5. The bottom equation could just be multiplied by +1. So in other words, it's not going to change. Yes. Now, the reason why I multiply the top equation by a negative, it's that I don't just need a 5 in front because 5 plus 5 would add up to 10, but I need a -5 because -5 plus positive 5 would add up to 0. So here it is. That top equation transforms into negative 5x, negative 5y, positive 20z equals to positive 20. So again, the bottom equation, I'm just multiplying by 1, so it's not going to change. And I could just go and add up these two equations. Excuse me, so I'll get no x, because 5x minus 5x is no x, but I'll get a negative 8y plus 18z equals to 20. So I've eliminated the x. All right. In the next pair of equations, I also need to eliminate the x. So this bottom equation has a 2x. If I just multiply the top equation by a negative 2, then that will do it. So I have now negative 2x minus 2y plus 8z equals to 8. So again, every single one of the terms on either side, nicely distributed. Adding these two equations, 2x minus 2x is 0. 6y minus 4y minus 2y is 4y. Plus 15z equals to 38. So what we have achieved here is to get down to a system of two equations and the same two variables. So it's a 2 by 2 system. All right. And now I have to solve it the way we did in 8.1. So I'm going to think about what can I multiply these equations by in order to, let's say, get rid of y. So it's really easy. As you see, 4 goes into 8 already 2 times. So a common multiple for 4 and 8 is 8. So if I just multiply the bottom equation by 2, so that'll get me 8y plus 30z equals 26076. So I doubled up every one of these numbers. I'll copy the top one underneath, just so we can have them next to each other. But again, if you can't think of a common multiple for 4 and 8, you can always multiply the top equation by 4, the bottom one by 8, and you'll make them both a 32, right? And one is going to be a positive, and one's going to be a negative. And the answer in the end will be the same. So we'll get a 48z equals to 96. Dividing both sides by 48 will get you that z equals to 2. Good. So we've found z. Now don't go anywhere because you need to finish this 2 by 2 system. In other words, continue until you found y as well. So finish up this 2 by 2 system like we did in 8.1. So plug in 2 for z now, and that should get you solving for y. So I'll get that 4y plus 30 equals to 38. So if I minus 30 from 38, I'm going to get an 8. So I'm minusing that over, divide by 2, so y is by 4, so y is 2. Okay. So I finished solving this 2 by 2 system. And I'll go all the way back to get x. And you can grab x from either one of these equations that has an x in it. I'll pick the first one because, well, it looks like the smallest numbers. So the first equation says x plus y, but y is now 2. Minus 4 times z, but we now know z is 2, equals to -4. Okay, so we'll get x plus 2 minus 8, and 2 minus 8 is -6. Add up the 6 over finally, so you'll get that x is also 2. So our solution is going to have the order triple, it's called. So we always have to put them in alphabetical order, so x, y, z, so 2, 2, 2. Okay. Let's try this again. Grab 2 sets of equations. It could be any 2, so I'm going to get the first and the second. And again, whatever variable you want to get rid of, it doesn't matter. If you want to keep it all the same and organize the same way and not have to think too much about what might be best, you can always just get rid of x first. You could also get rid of z because they have opposite coefficients already. But you still need to, in the end, grab 2 different pairs of equations and eliminate the same variable. So I'm deciding I want to get rid of x. Therefore, I'm going to multiply this bottom equation by a -2. And then I can add those 2 equations, the top and the bottom. So 2x minus 2x is no x. -1y plus 4y is 3y. 1z minus 6z is -5z. And 8 minus 12 is -14. Okay. Let's do the same thing here. Get rid of x. So I multiply the top equation by a -2. That way it's going to cancel to the +2 on the bottom. So I write it underneath. -2, multiply everything by -2. Okay. Add them up and you'll get 7y minus 7z equals to -28. Okay, so now I have 2 equations in the same 2 variables. I will put them together and finish solving this 2x2 system. Okay, so what can I do to get rid of either x or y? Well, not much. 3 and 7, 5 and 7. These are pretty much the same as, again, to get rid of y, I'd need to multiply the top equation by 7, the bottom one by 3, and one of them should change signs, as in one should be a positive and one should be a negative. So I'm going to go to the side this time, multiply everything by 7. So 21y minus 35z equals to -98, I believe. Okay. Multiply the bottom equation by -3. So -21y plus 21z equals to 28 times 3 is 84. Okay. So now when I add these equations together, as you see, y is gone. So I'm left with -14z equals to -14. Therefore, z equals to 1. I got z. I still need to finish this 2 by 2 system and get to x. I'm sorry, 2y. Okay. So pick either one of the equations. I'll pick the first one. 3y minus 5 times z is 1 equals to negative 14. Add the 5 over. So negative 14 plus 5 is negative 9. Therefore, y equals to negative 3. Okay. So I got z, I got y. Now I have to go all the way back somewhere to get the x. And pick either one of these equations you wish to get the x. So I'll pick the second one. That says x minus 2 times y is negative 3, we found, plus 3 times z is equal to 1, we found, equals to 8. So that's a plus 6, positive 6, positive 3. 6 and 3 is 9. So when I subtract 9 from 8, I'm going to get a negative 1. So here's my answer. Negative 1 for x, negative 3 for y, positive 1 for z. So again, your system solution should be written as an ordered pair, ordered triple, whatever they are. The variables have to be written in alphabetical order. All right. Here's another one. So, one more time. Actually, this one's pretty neat. If I pick the top 2 equations, and get rid of x, the bottom equation already has no x. Okay, so to get rid of x, I will multiply the top equation by a negative 1. So what that does is just changing all the signs. So negative 1x, positive 2y, positive 12z equals to positive 21. So when I add these 2 equations, I'm going to get to negative 1y minus 5z equals to negative 18. Okay. So now I compare this equation with the other one that already just had only, so I didn't have to get rid of x again because the bottom equation didn't have an x. So now I have a 2 by 2 system. Okay. As you see, negative 1 goes into negative 2 2 times. I also, though, have to switch the sign. Yes. To make it positive. So negative 2 times negative 1 is positive 2y. Negative 2 times negative 5 is positive 10z equals to a positive 36. And here's the tricky part, which actually turns out pretty good. Because if I add these equations, not only the y's eliminate, but also the z's, since 5 goes into 10 also 2 times. So we get 0y's, well, 0x's already because there's no x's. 0y's plus 0z's equals to 56, and that's just not right. A 0 never equals to 56. So therefore this system has no solution, which, as we said, is one possibility. Okay. All right. So let's try this one more time. As you see, I have one more system here for you. Again, you're welcome to try it yourself. So the first thing is that we're going to grab a pair of equations, and then we'll grab another pair of equations. Okay. So I'll multiply the top equation by 2. Because 1 goes into 2 times. And so that'll get me 2x plus 6y minus 2z equals to 4. So there you have it. Not only the x, y, and z go away, but also everything on the right side of the equation. Okay, so ta-da! Nothing else to do. We will get infinitely many solutions. You don't need to continue. The top equation and the first and the second equations really were the same. Okay, they represented one and the same plane. So 2 planes are going to, they could be parallel as well. So if you wanted, you could try another equations and see if you get no solution out of it. Then that will not work, because you could have 2 planes that are exactly the same and then the next one's parallel to it. So we could check, but I wouldn't trick you into infinitely many as long side with no solution. So it's just gonna, as soon as you get up to a 0 equals to something that's non-zero, you can stop. That's never gonna happen. And if you end up with a 0 equals to 0, that means infinitely many solutions, as you actually only are given 2 equations but 3 variables. Okay, so we're done.